This is Jeff Badger, the Grinding Doc, continuing my series on the great papers, the great research work of Professor Stephen Malkin. And this is number 8. Doesn't mean it's the 8th best or the 8th whatever. It's just I've just picked number 8, picked 10 of them, and I'm doing this one now. And Malkin was a professor mostly at the University of Massachusetts at Amherst. If you'd like to know more about him, I talk about him in video number 1. He has his own Wikipedia page, so if you got your own Wikipedia page, you must be important. I don't have my own Wikipedia page. The work done Malkin did in dressing, and Malkin dabbled in dressing a little bit, but most of his work was done in grinding. But he did do some good work in dressing, so we're going to talk about that paper here. Here he is with Murray at SUNY Buffalo, and this is when he was in Haifa, when he had moved to Israel. And so there are 2 papers on dressing. I'm going to go through these quickly. This is rotary dressing. Now, probably the greatest paper on rotary dressing, I could get in trouble there if I say the greatest paper, was a guy named Schmidt back in 1968, a German guy who did his Ph.D. thesis on Abrichten of Schleifscheibe or something. I don't speak German, but I know those 2 words. And it was a classic rotary dressing paper that people still reference today, and it was fabulous work. Malkin did this in 1978, and here we have this basic rotary plunge roll dressing. Good stuff. He measured with a dynamometer. He did it right, putting the dressing roll on the dynamometer. And then Malkin did it at different, this was probably his biggest contribution, I think, was doing it at different types of diamonds, different diamond densities. And then he measured the vertical dressing force component, which Barbara Linke did later, and she got more publicity for it. Malkin didn't get much publicity for dressing forces in this one, but there's some good significant stuff there because dressing forces contribute to chatter. He did it at different speed ratios, so he's continuing with the speed ratio based on Schmidt. And then he's telling us what those forces are at different depths. And he's telling us here what the specific dressing energy. And I often preach that say, hey, Malkin's papers were good because he did everything from first principles. It's Friday evening. I'm filming these before I go to dinner. I'm going to dinner at Bliss Restaurant in 27 minutes. And I'm rehydrating. So this is specific dressing energy. And Malkin did it from first principles because what is dressing? If you're doing single point dressing is a turning operation. You're basically just turning the workpiece, and the workpiece is a grinding wheel. If you're doing rotary dressing, like here, rotary plunge, you're doing cylindrical plunge grinding, and the diamond roll is the wheel, and the grinding wheel is the workpiece. So this is exactly how it should be done. He's measuring specific energy here. He's showing us that specific energies are only about 1 joule per cubic millimeter, where in grinding they're typically 50 to 100. So dressing is a much more efficient process, and he's using first principles to tell us, hey, how does that apply this specific energy to grinding or dressing? Because dressing is just grinding. So fabulous. And then he tells us, hey, the horizontal force, normal force, horizontal force is at its maximum when we have pure crushing, which is very important in terms of chatter and deflection. And I was at a company in Italy just a month ago, and they said, hey, how can we plunge roll dress faster? And I explained to them the concepts of normal force and then changing the speed ratio to be anti-directional when you dress in your wheel, which is going to make it dull, but it will give you smaller forces so you can dress faster, and then you can switch back to uni. And I didn't know that. I am basing that on the work of Malkin and later on Barbara Linke, a German woman who from Aachen or did work in Aachen on that. Okay, and then we've got more stuff. And then Malkin looked at SEM photos of the wheel to say, hey, does the wheel look different based on the dressing parameters? And it does, and I've seen this from other studies. I sponsored 2 Italian students in Sweden a couple of years ago, and same rotary dressing, and we could just see the difference between a sharp dress and a dull dress, and then it manifested itself in the amount of loading that occurred during grinding. And we may see that here. Is that a loaded wheel or a dull wheel? I'm not sure. So that's what Malkin did. And then this is a fabulous curve right here to say, hey, look at this. Nope, not that curve. Now, maybe it comes in the next paper. That's still a pretty good curve, though. Interference angle versus the specific dressing energy. Or how aggressive are you? And then how does that affect what the dressing energy is? And then the other Malkin paper was where he compared rotary dressing and single point dressing. So here we are, and he gives us some test results. He shows us some SEM photos. He shows us how it's different between a sharp dress and a dull dress. He shows us that, there's not a huge difference between dressing, rotary dressing, and single point dressing in terms of its impact on the wheel. And like I've said before, quite often Malkin gives us stuff, and there's other things on the side that are interesting, like this. This is wheel collapse. I wrote a cert paper on wheel collapse where the power is going up with wheel doling. And then we get catastrophic quick wear right there. I probably referenced this to show where other researchers have found it. And then surface roughness of the workpiece based on different leads and how the surface, if you have a faster dressing lead or a dressing depth, you will get a bigger dressing depth, you will get a rougher surface finish. Here he shows the difference between rotary and single point in terms of grinding energy. Not dressing energy, but grinding energy. So he's saying, okay, if you have more dressing energy from a dull dress, you're also going to get more grinding energy because you have created a dull wheel. Fabulous curve. This is the way it should be done. It's based on first principles. And then what's unique about it, he says, hey, for a given dressing energy, you're actually going to get lower grinding energy or lower grinding heats or less rubbing than you are with rotary. And that's an interesting finding right there. And then this he pulled from his work back in his MIT days, where you start to get catastrophic wear when you start to get burn. And then this one here is a fabulous curve. This might be the best one in the paper, where we say, okay, what is the surface finish and what is the energy, specific energy in grinding, not in dressing, but in grinding. And then there's a direct relation. And it says, okay, you can have it both ways. If you want to get a lower specific energy, because it'll give you less risk of burn, you are going to get a rougher surface finish. We just can't fix that. There's no way to help you unless you switch to a smaller grit size. And that's why I preach in my courses, if you can't get the surface finish you want, don't make your wheel dull, switch to a finer dress. And then what Malkin also showed here was that it was pretty much the same for rotary dressing and single point dressing. Not much of a difference. So there we are. So this is Jeff Badger talking about the great papers of Professor Stephen Malkin. And this particular paper, two papers, were the work that he did in dressing, both single point dressing and in rotary dressing.